Question 1a. When we're differentiating trig functions, we go to the formula sheet and just check what the derivative will be. Differentiating cos gives negative sine. 5 cos becomes negative 5 sine 3x times 3. We always differentiate the expression for x. In question 3b, this is a very typical sort of question for Achieved. There's always going to be differentiating something in brackets. So the power from the bracket comes out the front, 2 times 3x squared minus 5x, reduce the power to 1, and then we differentiate inside the bracket, and this second part has to go inside brackets itself. It has to be brackets 6x minus 5. When we want the gradient, we substitute x equals 1 into our gradient equation. Gets 2 times negative 2 times 1 equals negative 4. That's the gradient for our tangent. Here we ask for the gradient of the normal. The two gradients multiply to negative 1. So it's negative 4 times a quarter is negative 1. The gradient of the normal is positive a quarter. You need to know how to use the quotient rule and the product rule. Question 2a is a quotient. It's a division. So we start off by, we square the denominator to get 2x minus 1 squared, and then put that on top of the fraction. Differentiate the top line, 4e to the 4x minus, then it's just e to the 4x times 2. And question b is another one from our tables. When we look up log on the derivative table, it gives 1 over x. So log 3x minus 2 becomes 1 over 3x minus 2. 8 log 3x minus 2, 8 times 1 over 3x minus 2 times 3. Always differentiate that expression for x. The 3/8 become 24, and when x equals 2, the gradient function 24 over 4 equals 6. And question 3a, a second question in this paper, we are differentiating the bracket. Now the cubed root is a power of a third. The cubed root squared becomes a power of 2/3. That's our first step, change from the third to the indices expression. Differentiating that bracket to the 2/3, 2/3 comes out the front, and reduce the power by 1, goes down to negative a third. And again we differentiate inside the bracket, and that answer goes inside brackets itself. So you must have the 2x plus 4 inside brackets. And the last of our achieved questions, we start by bringing our x up onto the top line, so it becomes 32 times x to the power of negative 2. Differentiating 1 minus 64 x to the negative 3. For a stationary point, we're going to put that gradient expression equal to 0. So solving it, we start by bringing the 64 over x cubed to the left hand side, it becomes positive, and then I'll cross multiply 64 equals x cubed, the cube root of 64, x equals 4.